Now, the second type of bonding we're going to discuss is covalent bonding. And this is any time you have two nonmetals. As you might remember, nonmetals tend to gain electrons to become stable. So what happens when you have two nonmetals that both want to bond together, but they both want to gain? Well, what happens is they end up sharing electrons. Now, they have two options. They can either share those electrons equally or unequally. So we have two types of covalent bonds. You have polar covalent. That's when electrons are shared unequally. Now, for this, I want you to remember our discussion about electronegativity. Electronegativity is when you have two atoms that are bonded together, and one of those atoms has a stronger pull on the electrons than the other one. So if you can remember that fluorine is the most electronegative element, it's the one with the strongest pull for electrons, then all the other atoms, all the other nonmetals, we're going to be comparing to fluorine. So if you have two different nonmetals sharing electrons, it's going to be an unequal pull. One of them is going to be more electronegative than the other. So it's going to be a polar covalent bond. But if you have two nonmetals that are the same, so if you had two oxygen atoms sharing electrons with each other, then that would be a nonpolar covalent bond. Two oxygen atoms have the exact same electronegativity, so both of them are going to be attracting electrons the same amount, so they end up having an equal pull. And you can kind of tell that by these images I have on the slide. The first image up at the top, the right side of that molecule is the more electronegative atom. That's where all the electrons are attracted. That's why it's a bigger side. The second image on the bottom, those atoms are sharing electrons equally, so you can see it's a symmetrical molecule. So now I'm going to show you how to draw Lewis structures for covalent compounds. So when you want to show that atoms are sharing electrons and electrons are not being transferred, I would prefer for you to not use arrows. So I'm going to give you two options. So in this first example, we have two hydrogens and one oxygen. So I'm going to draw oxygen. It has 6 valence electrons. Hydrogen, each of your hydrogens have 1. So here are your options. You can either draw a line connecting those dots and showing that they're sharing electrons, or this might have been the way you were taught to do it in physical science. I've seen students draw circles around the electrons to show that they're being shared. I really don't care which one you do. This is the way I do it with the lines, but it's completely up to you. Now for this, there's not a complete charge formed, but we do want to show that oxygen is more electronegative than hydrogen, so it does have a stronger pull than hydrogen. So what we're going to do is draw a symbol. It's actually a Greek symbol. It looks like this. It looks like an S that you either got a little carried away with or an 8 that you didn't quite complete. And this symbol means slightly. So oxygen has a slightly negative charge because it is the more electronegative atom. Since hydrogen is the less electronegative atom, hydrogen is going to have a slightly positive charge. All right, and we would say that this is a polar covalent bond. Polar covalent because they are sharing electrons, but it's not equal sharing. Oxygen has a stronger pull. It's definitely attracting the electrons more than the hydrogens are. All right, so we'll move on to our next example. Now we have two nitrogen atoms. Both of these have 5 valence electrons, and you can see that they can form 3 bonds with each other. And this is actually what we call a triple bond. whenever you have 3 bonds between the same 2 atoms, that's a triple bond. This is going to be non-polar covalent because you have the same nonmetal sharing electrons with another of the same element. So they have the same electronegativity and they're going to share electrons equally. For this next example, we have 2 oxygens. Both of those have 6 valence electrons. And those can form 2 bonds with each other. So we call this a double bond. And this is also going to be a non-polar covalent bond because those oxygens are the same, so they're sharing electrons equally. Just to contrast the double and triple bond with our original structure, this is water. These are 2 single bonds in the oxygen molecule. All right, lastly, we have CO2. So we have 1 carbon, and we have 2 oxygens. And I'm putting the carbon in the middle because carbon can form 4 bonds. These oxygens can only form 2, so we're going to put them on the outside. So you can see that each oxygen can form 2 bonds with carbon. So this is 2 double bonds, and I just misspelled double. Let's try that again. 2 double bonds. Both of them are polar covalent bonds because the oxygens are slightly negative and the carbon is slightly positive. And remember, if you're like, how does she know which ones are slightly negative and which ones are slightly positive? You're basing that off of how close they are to fluorine. Fluorine is the most electronegative element. Oxygen is closer to fluorine than carbon is. So we're going to make those slightly negative. The carbon will be slightly positive. So this little diagram here just shows you the difference between ionic and covalent bonding. You'll notice over on the left side, this is a covalent bond. You have 2 nonmetals who end up sharing electrons, and those form what we call a molecule. A molecule is covalently bonded together. On this side, this atom is losing an electron to this atom. So this becomes a cation, and this becomes an anion, and they are held together by their opposite charges. So that's an ionic bond. Now earlier I mentioned the difference between single, double, and triple bonds. A single covalent bond are 2 atoms that share 1 pair of electrons. So if chlorine and chlorine shared electrons, they'd only share 1 pair. So that's a single bond. That's going to be the longest and the weakest of the 3. Double bonds, I gave you an example just a minute ago. I showed you when oxygen bonds with another oxygen atom, they end up sharing 2 pairs of electrons. So that's a double bond, and those end up being a little bit shorter, a little bit closer together, and stronger than single bonds. And then you have triple bonds, and again, I showed you this example a minute ago. When 2 nitrogens bond together, they share 3 pairs of electrons. So those end up being even closer together than a double bond, and so those are the shortest and the strongest of the 3. So just remember, every time we form an additional bond that brings those 2 atoms closer together, that makes the bond shorter and it makes the bond stronger. And if the bond is stronger, that means if you try to heat it up, it's going to require more energy to break that bond. And this last bullet point is just a reminder of what lone pairs are. Those are the pair of electrons not involved in bonding. This next question is kind of, if you think about single, double, triple bonds, you might be wondering, well, what about quadruple bonds? Can those exist? And you might be thinking about group 4. Can 2 carbon atoms form 4 bonds with each other? And the answer to this question is theoretically it's possible, but you don't see this type of bonding in nature. Quadruple bonds just don't exist. And the reason why is every time we add an additional bond, those two atoms are brought closer and closer together. And in the case of a quadruple bond, those two atoms would be so close together that their nuclei would repel each other. The positive charges in the nucleus would just keep them apart. Kind of like if you took two south poles of a magnet and tried to put them together, they'd naturally want to separate. And the second question I want to discuss is hydrogen. We discussed that hydrogen is classified as a nonmetal, but it's grouped with the metals. And the reason why is hydrogen can act like both. It can act like a metal and a nonmetal. So my question for you is why? Why does hydrogen act like a metal and a nonmetal? And the reason why is hydrogen has one valence electron. So it can either lose that valence electron to be stable,